Very good day to my supervisor, Cik Sumaya, panel, Puan Rashida, and Professor Jamal. Today, I'm going to present about my final year project 1 topic, which is Recycle to Reward System using Programmable Logic Control, PLC, and Raspberry Pi, or we can call it as R2R system. In this presentation video, I'm going to summarize my reports into a few slides. Starting with Chapter 1 Introduction. In 2020, there's a lot of newspapers stated that Malaysia has become the largest plastic consumer in Asia, and it has a lower recycling rate compared to German recycling rate, which is 28 to 66.1. Similar with my system, a vending machine mechanism. Now I'm going to explain about the difference between the vending machine and reverse vending machine. Vending machine, we are using to use money to buy items, but reverse vending machine is in the opposite way. We collect the waste, recyclable waste, and then we convert into rewards, which may be in keychain or point or even cash. Problem statement: smaller the scope, UTHM Campus Bago does not have a proper recycle system and lack of a system that is separate, collect recyclable waste. My project objective is to design a R2R system for 355 milliliters, 500 milliliters size plastic bottles, and 220, 240, 320, 325 size of tin, and to make sure to program the sensors as input and motor as output depending on the condition of the inputs, and develop coding of RFID system and create a database for user, and also for the weighing scale and set the range material by using Raspberry Pi. And for the project scope and limitation, a PLC and a AC to DC converter is used in designing this project and read signal from the sensors. Raspberry Pi is used to read the value of the load cell and convert the value to reward system, and read signal from the ultrasonic sensors and adjust the angle of the servo motors. For the limitation, it only can accept a few size of the plastic bottle and aluminium cans only. Glass bottles are not considered. As for the expected result, the process of R2R system is fully automated, and the sensors are able to detect based on the characteristics, and the output are able to sort and reject objects based on the characteristics as well. The points will be given to the user by measuring the weight of the object based on the rate preset, and then the integration between PLC and Raspberry Pi carry out a successful result. I will going to present about the Chapter 2, which is the literature review. In this video presentation, I will just base on the summary of studies, and I will short form it in a very short way. In most of the study, the controller they are using PLC, Arduino, Raspberry Pi as their main controller. As for the sensors, they are using inductive proximity sensors, RFID card reader, load cell capacitive proximity sensors, and ultrasonic sensors and photoelectric sensors. In most of the sensors, they are trying to detect the characteristic of the object and try to differ it from the others and sorting it. As for the card reader, they are trying to recognize the user ID. As for the load cell, they are trying to use the load cell to weight of the object in order to convert point back to the user. As for the output, servo motor is used to receive the signal from the controller to rotate to perform their task, and relay is act as a switch by energizing the coil of the relay, and it will be triggered by using a small signal to trigger it to a larger voltage component. LCD is used to display the message from the controller, and solar panel is used as an extra power source for the project. There are still some extra outputs and inputs inside my reports, but I will pick up some important part inside these slides. As for the proposed project title, which is as stated in front, which is Recycle to Reward System using Programmable Logic Control and Raspberry Pi. The hardware that I'm going to use is Raspberry Pi, Programmable Logic Control, Power Supply, HX11 module, DC to DC step-down converter. As for my software, I'm going to use Python programming to program my load cell, servo, motor, and converting point system. And I'm going to use CX Programmer to control my PLC by using the ladder diagram. The input, I'm going to use capacitive proximity sensors to detect the presence of plastic, and inductive proximity sensor to detect the presence of metal, ultrasonic sensor to detect the storage bin for my project, and 1 kilo load cell with HX711, which is to weight the weight of the project. RFID card reader to make a database for the user, And for my output, I'm going to use 12 volt DC motor and 24 volt DC relay, LED green and LED red, and also the servo motor as well. Now I'm going to present chapter 3 methodology. This is a flowchart of my project planning. Now I'm going to explain about my part 1 of the system flowchart. The system will start initialize and start to read the ultrasonic sensor, which is a full beam sensor, to detect whether the beam is whether full or not. If it's not, then we start to read the card reader, and then we will send data to the Raspberry Pi. Is it the user ID or is there no user ID? If no user ID or whether got, we will still run the plastic sensor and metal sensor to detect whether there's object at there, because we are not sure whether the user are going to touch the card first or they will try to put the item in it first. Therefore, if there is a user ID, then we will try to use the sensor to determine whether it is metal or plastic. No matter what, it will still send the data to the Raspberry Pi, and then it will trigger it. And the part 2, which is a E, which is display bin is full out of service in the LCD, and send email to the creator emails, which is my email. When there is a bin full, it will notify me. And B from the part 1, BC, it will turn to read load cell and then send the Raspberry Pi to send data to the Raspberry Pi, which is we will try to read the weight whether it's within range or not. If it's not, then we will set the sorting servo to the reject bin. If yes, then we will set the sorting servo to the respective bin, either the plastic or the metal bin, and we will trigger the holder servo and let the item drop it. And lastly, we will display the message in the LCD, and it will start looping again. This is a system design which is same as a flowchart in front. The object is dropped from here, and then it will scan it with the sensor, using the sensor, and then if there is the object, then we'll turn on the DC motor, and then the item will drop on the holder and also the load cell. The load cell will try to weight the weight of the object, and then it will depends on the data from the sensors. The Raspberry Pi will make decision whether this item will go to reject or metal or plastic bin. Before the holder servo is moved, the sorting servo will move first to the direct bin to make sure it will drop in the correct bin. After the sorting motor is already set the angle, the holder motor then will turn it and let the item drop on the slide and then slide down to the respective bin. And this is the block diagram. This is the wiring diagram. The summary of the wiring connection is listed inside the reports. I'm going to present the 3D design of my system. As you can see, the item can drop it from here upstairs and go down to the sensor and check it. After that, this have a DC motor connected to here, and this is a trapdoor. And it will goes down to the holder and also the load cell. Before the holder servo to move, the sorting servo will move to the respective bin, which is the reject, metal, and the plastic bin. After the sorting servo change the direction to the respective bin, then the holder servo will sort the item to the slide and then slide it inside the respective bin. I'm going to present chapter 4 preliminary result. This is the Raspberry Pi setup. I'm using mini HDMI connected to the monitor and then connect to keyboard and mouse and the 5 volt supply to the Raspberry Pi. This is a combination of the load cell and the servo motor testing. This is a testing of the inductive proximity sensor. The left hand side is a connection of the testing, and then the right hand side shows that the inductive sensor able to process. And the data collection. Each kind of tin and plastic are going to collect their weight, and then I will make it inside a table and I listed inside the reports. Furthermore, data collection will be due. That's all for my presentation. Thank you.